Welcome to From Cover to Code, the Technology Book Club. Join us as we discuss artificial intelligence, DevOps, software development, cloud computing, and more. With your hosts, Angela Andrews and Michael Jenkins. The next episode of From Cover to Code starts now.
And we are live and in the building. How are you doing today, Angela?
Blessed and highly favored. I am.
Amen.
Awesome.
Amen to that.
How you doing?
I am doing so much better than I was the last time we got together. Let me tell you, I was not well during our last discussion, but I think I said last time I was going to be 95% better. I'm 100% better.
Yay!
I'm just happy to be here and get into this discussion. So
Very good.
I'm doing good.
I'm glad.
Cool. Excellent. And thanks for everybody who's joining us live, Facebook, MySpace, Instagram,
All the places.
All the places where we're streaming live or you're catching us on the replay. Thanks for joining us. We really do appreciate having you along for these discussions. You make it so much more fun.
That's the God's honest truth. And one of my old coworkers, he messaged me and he was like, I'm gonna have to join one of your streams. I have the book. I'm like, well, Wednesdays at 5 o'clock. If you ever want
I know, right?
Right? Come on, come through. When I say he was probably one of the nicest people that I've ever worked with. Hey Lloyd, if you ever join or you watch this, very smart. So if he ever joins, he always adds so much value to any conversation because he's just such a smart person and he's such a helpful person. So anyway,
excellent.
Hope one day he may join.
And we will definitely shout him
automation. He's an automation head. Like that's his bag. So we're speaking his language. Awesome.
Well, we are deep into Terraform Up and Running by Jim Brikman. Angela's holding up her paper copy. I'm holding up my Kindle copy right here. As it is Kindle and Audible. I listened to it a lot of it this time around as well. But yeah, chapter this time we're talking about chapter 7, working with multiple providers. At this point in the book, we've gotten through the basics. We got through the modules, variables. What was last time? What did we talk about last time? I'm on a blank on it as it is already.
Wait a minute. Let's secrets, chapter 6.
Secrets. Yes. Security, keeping our API keys and passwords and all those credentials out of places where they should not be. Like first rule, don't put anything in plain text anywhere if you can avoid it. So that was important. And here we are now talking about multiple providers. Another one of the what I consider to be like the superpowers of Terraform.
I don't disagree with you. The flexibility of being able to run code in different regions, in different clouds, in different accounts. We covered an example like that. That's pretty cool with one tool. So chapter 7 kicks off telling us, it's going to answer questions about what if you need to work in multiple regions? Well, what if you need to work with multiple copies of the same provider? What if you need to work with multiple different providers, i.e. HashiCorp? Not providers, AWS, GCP, Azure, because a lot of things are multi-cloud now. To some people's chagrin, there's a lot. There's always a lively conversation on LinkedIn or somewhere. It's usually LinkedIn where somebody's talking about doing multi-cloud and just the level of complexity of it. So even if you do, Terraform is definitely your friend because it is capable of doing such. So let's get into it.
Yeah, no doubt, no doubt. So he starts off by talking about what is a provider itself, and broke it. Well, I was going to say two categories, and they're sort of like what we call the core provider, which is essentially the Terraform binary itself, and that's what HashiCorp builds. They share that. You can download it, install it, and that gives you the basic functionality that's used by all platforms or all the providers that it connects to. And then these providers are like plugins that connect to the core Terraform provider, or whatever you want to refer to it, and it extends it to be able to talk to that particular thing. So you mentioned multi-cloud. There's an AWS provider, there's the Azure provider, the Google Cloud provider, the Oracle Cloud provider, and in pretty much any DigitalOcean. There's a DigitalOcean provider as well. I've used that one back in the day. So pretty much any cloud that you could think of, there's a provider for it that connects into Terraform that lets you, define your resources that way. But even beyond that, there's all these other providers that are, enabled to work with Terraform as well. And I was going to try to get a banner ready for this so I could put this on the screen. If you want to go to this particular link, registry.terraform.io/browse/providers, you'll see that there are thousands, literally, of providers across all different kinds of categories: asset management, communication, container orchestration, CI/CD, data, database, logging, networking, and on and on. I'm not going to
name it.
Exactly.
Okay, it's a lot.
We got cloud.
Yes, it is a lot. And then of course they come in various flavors. They have the official providers,
yes,
the ones that the companies are creating and up and maintaining, and then they have their partners, partner premier. Never heard of that one, but anyway. And then of course community. If you or I were to create a provider, we could share it in the community and have other people use it. So a very vast ecosystem for the number of providers that are available. All the I'm looking here now, and there are clouds I've never heard of. There's it goes pretty deep. It does go pretty deep. So wherever your workloads are, there is probably a HashiCorp provider that allows automation against it. So
yeah, and then if there isn't, because it's a extensible system,
yes,
you can develop your own provider as needed. Because really, when you boil it down, it's like Terraform's like an API orchestrator, So if you can write the Go code that connects an API and helps you manage resources, CRUD operations, that type of stuff, then you can make a Terraform provider. But I don't want to beat a dead horse talking about what is a provider. There are thousands of them. Look in the toy box and have fun. Just pull all the providers you need out of there and just go wild. After describing what a provider is, he went on to talk about how do you install a provider, and it's pretty magical.
And we've seen the magic, didn't we?
Yeah, we've already done it. It's like you don't even really have to do it because you've already done it. You just say provider, you put the name, and even like I've done it configurations where you don't even put anything after that. It's just an empty curly braces. You just give me the default whatever provider is for this thing. Terraform's going to find it one way or another. It's going to give you something. And it's as simple as that.
It is that simple. And the author did explain, we've been doing it all along, super simple. But you should be more definitive. You should be more, what's the word he used? He used some word. But anyway, you want more control on how and what Terraform installs on your system. because depending on what version you have written your code in, uh, and if you're moving around and not stipulating the version, if you go up a whole point version, some of the functionality may have been deprecated. There
Yeah.
may be new functionality and you're not onto it. So there's something called constraints, and he did talk
Mm.
about that. I don't know if I'm jumping the gun, but
No,
um,
you're good. You're right on point.
okay, making mention of uh, be very explicit with the version. You can
Yeah.
give it a version range. You can say doing, it doesn't have to be a major, it can be a minor, it can be a patch version. Um, and, it has different indicators: greater than, less than, equal to, and then the tilde less than sign,
Mhm.
or tilde greater than sign, which is, I think we may have used that, or I've seen it at least, where you're saying we want anything in the 4.0 family and we're
Mhm.
good to go. So as long as you don't go up like a whole point version to 5 where things could break,
Yeah.
you're usually pretty cool. But he did make mention of that. Like, you want
Yeah.
to be really specific, because you don't want your I'm about to call them playbooks. What are they called?
Providers.
Okay, yeah.
No,
Yeah,
yeah.
you don't want your
It's all
providers
it's
break.
all good. And I didn't I mean we talked earlier how I've got a couple testimonies from this chapter. I
Hmm.
didn't put a testimony for this one, but it just our discussion here jogged a brain cell where I'm trying to recall there's a big kind of kerfuffle where Terraform for some time had these like common cloud providers embedded in the Terraform binary itself.
It
So
sounds like Ansible.
AWS, yeah, very similar, and they broke all their stuff out too.
Yeah.
So AWS, Google Cloud, Azure, they were all embedded in the Terraform thing because they were like, hey, we'll just kind of give people the option to use them by default. But then it was harder to manage the Terraform binary itself. So they're like, you know what, we're going to break everything out to these providers. And so people who were kind of moving across these different versions of Terraform, they really had to rely on these required provider block within their provider configuration to say, okay, I want this one and I want the HashiCorp one that comes from here versus the AWS one that comes from here.
Okay,
And
I see
there
where
was
we're
a lot
going.
of version, yeah, mismatch all over the place until people really dialed in their configuration and they didn't get all this drift. Because if you did like a Terraform init dash upgrade or update, I forget whichever what the switch is, but you're going to get like the latest one from wherever your default configuration was.
Mm,
So you have to be very specific with the version. And so if you say upgrade, it's not going to upgrade because it's like, no, you're good where you are. You don't need to upgrade because you might break something, and it was a very interesting time, I'll say, to be
okay.
working with the providers in Terraform.
So that's behind us now, right? Because
Yes, no, we're
they've
good.
removed they've removed those baked in providers, and it is
Yeah,
just core Terraform. And
yeah,
however your required providers block is, will drive what provider and what version of the provider that you'll be installing. So
exactly.
cool.
Um, yeah. So then he gets into like the fun ways that you can sort of mess around with these providers, and the first one was working with multiple copies of the same provider.
Mm-hmm. Mm-hmm. Oh
Um,
yes. Uh aliases.
yes, yeah, and that's like where it's definitely the key to making everything work. I'll just simplify it by saying that, but you can have provider blocks that look very similar, and you say, well, I'm going to call this one because I want to set it up for US East 1. I'm going to
Mm-hmm.
give it the alias like, AWS East 1. And then I'm going to set up this exact same block, but I'm going to set its region to US East 2, and I'll call this one AWS East 2 or something like that.
Right.
Well, then when you refer to that resource, or when you refer to resources that you're creating in whichever region, then you tell it specifically which provider to use based on the
Exactly.
alias. Yeah.
Inside of your resource. Now, we did come to the part where they said this is not ideal.
Yeah.
You should definitely be segmenting out your code in such a way, especially if it's in different regions. Like, he always talks about the buyer beware. Like, don't have too much in one space, because you could do damage to prod or something else. And in this case, you could wreak havoc in a whole nother region that you weren't even intending.
Yeah.
So aliases are great, but your mileage may vary. Like it's just giving your provider a nickname and things like that. So I get it, and I went through that exercise. I was like, "Whoo, this looks cool. All right, fine. I'm just gonna deploy a little instance in USC West 2 and did it." And I was like, "Okay, I understood that part." But then, of course, when it gets to the part where it's like, "Well, things are different." At least AMI wise, like when you're installing those AMIs, when you're doing it in one region and another, it's like, bump your brakes, because this doesn't exist there. But there is this cool filter that you could use to say, hey, where am I getting this from? And in the book, he look at your little razzle dazzle. Okay.
Well, I had to get fireworks for that. I'm really excited. Yeah. Go ahead. I'm sorry to interrupt. Go ahead.
Yes. So when I'm laughing because he's a Mac user and he just gave me 2 thumbs up, and then all hell broke loose. It looked like the 4th of July over there. So that's what I was laughing at. If you're listening, just watch the YouTube video so you'll know what it was. But it was like, okay, great. Let me figure out the owner of this particular. I didn't do Ubuntu. Like, I'm not a Ubuntu user. No offense. Give me Amazon Linux, RHEL, whatever. Give me those. So I was like, okay, let me find it. Well, they have this cool thing called a filter. If you just put Amazon in quotes, not even the account number, and you put your filter, it will automatically download the latest version of that AMI into your region. So I had 2 different Amazon Linux instances running, and using that really cool feature called a filter. So I'm assuming that you could, well, I don't know, other than AMIs, is there any other resource that you can think of that's regionally different?
There may be some like parameters or roles or references to other resources that are based on, like, the naming convention might have the region baked into it somewhere. But if you're Googling that, I gave you the thumbs up fireworks because I was so excited that he finally got to using filters for AMIs in this book. And let me, if you don't mind, I'm going to pull out my soapbox for just a second, and I'm going to stand on top of it. So, it happened in this book. One of the things that I don't care for when people talk about Terraform, specifically with AMIs, and maybe some of the other resources that need, region references, is that you may have like, say you want to work through their example code, and their code has baked in this AMI ID and has maybe they don't even specify the region, or they say, hey, do it in US East 1, and you overlook that, but that AMI is baked in there. Meanwhile, and this is where I come in personally, your environment is set up to use US West 2 because you happen to be on the West Coast, so you're closer to West Coast data centers, so you just use US West 2. But then you run the code and you get errors. Now, I can look at the errors and I say right away, like, oh man, AMI is hard baked, or it's baked in there, hard coded. I got to fix that. But for the uninitiated, they may be like, I copied this code perfectly. I know that my environment is set up. They run AWS STS, identify, your profile, you're logged in, you can run commands, everything works. And then you run the Terraform, and the Terraform, well, your plan is going to be correct.
Yep.
Your format is going to be correct. Your validate is going to be correct. Everything is going to look good. But then when you run that apply, it's like, hey, I can't find this AMI. And you're like, I copied this code verbatim. I know it's correct, but it's all because the AMI is not found in that region. So you have to figure out what AMI can I use in this region, et cetera, et cetera. But the people who provide the code can work around that by saying, hey, here's a filter for this particular AMI type, account, whatever it is. Find this particular AMI ID for this region where this code is running, and it just kind of fixes
And it
everything.
works.
So I'm so glad that he, brought that to bear in this particular chapter, working with multiple providers. So I'm getting off my soapbox now and putting it away for the time being.
Well, that is definitely almost like a must-have if you are dealing with deploying resources in different regions. So what I found, like AMI, is there are hundreds of regional compute, storage, networking resources that are completely independent between regions and must be configured or deployed separately in each. So knowing that, you understand, like, this filter option could be a game changer between, I copied this code verbatim, I did a copy and paste, what are you talking about, to being able to filter down depending on what region and what resources are available in that region.
Yeah.
So I could see that's definitely a value add, being able to do something like that, because you'd be hard coding stuff everywhere.
Yeah. And there is this is a point where I did have a testimony. It doesn't, no soapbox involved. This is a planned and scheduled testimony, folks. So I'm not going to pull out my soapbox for this one. But the one sort of exception where he indicates this in the book, and I've lived through this many times, is where if you're using CloudFront as your content distribution network, and you want to create a TLS certificate for your endpoints that are working with CloudFront, you have to create that certificate in US East 1.
Yes.
Just it doesn't matter. You could be running in Asia. You could be running in US West 2, Canada, Antarctica. Mars. I don't care where your data center is that you're tapping into for your CDN. But for this certificate, it has to be defined in US East 1 for CloudFront. So in these cases where I have had to set up CDNs, I do have two providers. I've got that alias, and I might even call it like CloudFront's provider, or, like I just call it the CloudFront, or something like that. So then provider equals CloudFront, and it's going to do its thing because it's already configured for US East 1. Everything's good. And then I can reference that certificate from my resources that are actually being deployed in US West 2 or wherever they're hanging out. So that's a very valid use case.
That is. So you were talking about CloudFront. It can be used throughout. It's CloudFront. It's a global service. However, because it handles its global control plane and security replication entirely is done from US East 1. So it's I didn't know that. I mean, I take it for granted because I live on the East Coast. But you, sir, on the West Coast, you're like, oh, if I'm just going to create my cert here, and it's like, can't do it. There's reasons behind it, and some are enumerated. Just Google it, and it'll be enumerated as to the why. But we know US East 1 is that girl, so it kind of makes sense as to the why. But anyway, filters, and more filters.
Yeah. And I will say that CloudFront one, if you ever get to the CloudFront, and I'll leave it alone after this, is that it's not like, I was definitely uninitiated when I came across it, because I was deploying websites that were fine with the certificates that were defined for the load balancers where they were. So you can do AWS certificate manager in your region, store the certificate there, and use it on a load balancer in that same region. So I was good. I was like, hey, I want to use this certificate that I'm already defining for my CloudFront thing. And Terraform's like, hey, valid configuration, you're good. And go to apply, and it's like, that's not going to work, because the AWS provider, in this case, the interface to this API is like, you can't do that because that certificate is in the wrong place. So you need to do something different. And it's immediately not aware, but then you do the research, like, oh, CloudFront, US East 1, set of that provider, give it an alias, create a new certificate in US East 1, and then use that for your CloudFront. And you could still use your region local certificate for your load balancer. It's a mess, but it works.
It is what it is. Okay. All right. Well, that's a teachable moment. That scenario is a teachable moment. All of us,
indeed.
I'm speaking from a place of privilege. I do everything in US East 1, and stuff just be working.
Yeah, right.
But there are people all around the globe who've run up against this just like you did, and they had to figure it out and understand the why behind it. And then now that you know, it's like, okay, well, it's just this is how it works. And of course, like I said, if you look it up, they're going to give you reasons as to why that is.
Mhm.
What are we doing? What are we talking about next? So we talk about the filters.
Yeah. Well, next up is multiple AWS accounts. And so he's
Yes.
jumping out of regions
Okay, let's
and then
turn
taking
page.
it up a level to accounts.
Yes. So
Starting around page 238, I believe.
238. Okay, wait. I'm a little bit oh, why am I looking at multiple?
Your page numbers might be different than mine.
No, it's not. You are absolutely correct. I stopped too soon. No, don't worry about it. Working with multiple AWS accounts. So there is a demo in here that you can do, but you think about why most organizations have multiple accounts. Usually each team has its own accounts, dev, test, and prod, or impl, whatever the naming convention is to isolate their workloads. And just how we do it in Terraform to make sure that we keep things separated. We want things separated in these various environments. So working with multiple accounts, yes, you could very well have permissions in 2 accounts to do something, but you have to make sure that you are authorized and authenticated into that account. So if you're looking at the book, you'll see if you can go into organizations and you can add an account that way, which is great. Oh, side note, if you're so remember the old AWS SysOps exam, and now it's turned into the cloud engineer. That if you ever study for that exam, you're going to get your first touch of organizations. If you think about it, if you're studying for the solution architect, or if you're studying for the DevOps, the developer, whatever one it's called, you don't get to do that stuff. And if you work in an organization, you are not usually, at least the size of the organization, you're not responsible for managing the overall organization. Someone's handing you creds or giving your account access, and you're just working in your myriad accounts. But organizations is taking it up a notch, where you can create multiple accounts based on one account, arranging your accounts in certain OUs to make it make sense. So I say all that to say, yes, Terraform can handle you being able to work with multiple accounts. But if you're interested in creating multiple accounts to do this exercise, or to do any type of exercise, know that that's what you'll be learning if you're studying for the old SysOps, new cloud engineer. It was so cool. Yeah. It was so cool.
Yeah, and I totally support that statement. I have to back everything that you just said. And I think it's really important, like to your point, a lot of people, when they're sitting in a company or wherever they work, they log into AWS. Somebody has said, hey, here's your login and have fun. You're good. Maybe if they're on a team that has multiple accounts that they manage themselves, then they'll say, well, okay, I'm going to log into this account and I'm going to assume a role in the dev environment or the dev account. I'm going to assume a role in staging. I'm going to assume a role in production, et cetera, et cetera. But anybody can go to AWS organizations and see how this stuff works. And so when I saw that was a thing, I was like, okay, this is kind of cool. And even in my free tier accounts, I go to AWS organizations and I create multiple accounts. And I'm like, I'm going to start here for this particular project. It's isolated from all the work that I'm doing over here. I'm going to go and create this account for this project. And it's isolated. The one benefit, though, is even if you have the separate account, they're still tied to the same like the finance profile. Yes. So you're you don't have to put billing. Thank you. You don't have to put multiple credit cards or root email addresses on all these sub accounts or child accounts. You still have your root account, and you can add credits and pay your bill and everything at this root account, and it covers all of your child accounts. So that's it doesn't, what I want to say, it doesn't complicate the management of all these accounts. It really kind of simplifies it
It
because
does.
you can see an overview of everything from one particular spot. And anyway, once I saw I could do that, I was like, I'm not going to try to get like another email address to create
Yes.
another account and do all this other kind of stuff. I'm just going to create, in this account that I already have, a sub account, and then I'm going to use that one.
Now that I've learned that little ditty, and I have multiple accounts in my organization, I'm thinking about the accounts that I created 10, 12, 15 years ago that are literally sitting there with crap in S3 buckets.
Yeah.
I should bring them into the fold or get rid of them.
Yes.
Like I haven't decided what to do yet, but organizations gives you that one-shot deal. I'm the account, I'm running all these, it's on one credit card. You're not getting 7 different AWS bills in your inbox it does make management so much easier. So now that we've jumped off our AWS organization's soapbox,
it keeps coming out.
I know, but you can there is an example where you can link accounts. You can have one credential assume a role in another account and run your Terraform. And there is an example in here. I don't know. Yes, there is an example. You're just doing outputs. You're not really deploying anything. You're just pulling information out and being able to see what is the account for said output. So it's just showing you that, yes, this information is coming from a separate account. So with that in mind, then you can understand, okay, I can understand how I can do a little something in this account and I can do a little something in this account. It's really all about what your access is and if the role that you're assuming has the access to perform those operations. So
and that's the key. You nailed it on the head, is assuming that role from the other account so that you can access the capabilities over there. And he did also mention a warning for the people who are security conscious, that when you're using even if you're saying in the same organization, cross account IAM roles, you have to opt in from both accounts. So you have to say in account 1, I have a permission to access account 2, and then account 2 says, yes, I agree that account 1 has permission to access my stuff. Because you could get anybody's account number. If that wasn't the case, you could get anybody's account number and just say, hey, I'm going to assume a role in your account, friend. And just go crazy. So you have to do it both ways.
You think about how many demos you've seen where you can see somebody's account number. That's never. But like you said, that is a control in place. Both sides have to agree to be a part of those that cross account access.
Yeah.
And and there's another warning, and I already mentioned it. Use aliases sparingly.
Yeah. And that's what I say, like the one case that I know I'm gonna use that alias is for CloudFront. And that's it. Yeah, that's pretty much the one that I stand on. Otherwise, you shouldn't go too crazy. I would say, have your Terraform plan and configuration for one account, or cross accounts can be fine, but for one region, no aliases, another region, no aliases, and then you just kind of work it that way. Separation of concerns as far as regions, aliases, and accounts go.
Agreed. What's next?
Next up was creating modules that can work with multiple providers. I didn't go into this one in too much detail.
Yeah.
He gave some examples as far as of course, we know what reusable modules are. These modules that we can kind of use like Legos or building blocks across the board. And the root module is one where these Legos are kind of stacked together and you actually run your Terraform apply. And there, he goes into like some techniques for calling out the provider that is required for the low-level module. But this is just my experience. I haven't had too much opportunity to say, like in a child module, what AWS provider, I guess specifically, is required down to the version for that module. But I guess, if you have a certain style of code or resources that or maybe you're worried or concerned may change, or even you just want to kind of lock it down,
Mhm.
then I mean that's probably a good reason to say, hey, if you're using this module, then you should be using this particular provider and it should match this version string. So I understand it. I just haven't had the opportunity to do that with any modules that I've created.
Okay. Well, your mileage may vary with that one.
Yeah. Yeah, indeed. Somebody's going to benefit from it though. I know.
Of course. That's there's so many different use cases. That's why it's available. All right. So they do talk about how defining blocks within reusable modules is an anti-pattern. Now, we've done it, right? And then he goes back to say, just because you can do something, you shouldn't. So he goes and enumerates why that is problematic, and you can have configuration problems. They were talking about like the number of variables. So that's one, and then of course you can having duplication problems, because if you expose 50 settings in your module, and then then you have to pass a subset of those over. So I can see, like, I haven't done this exercise, but I can see how that can be problematic. And then, if you have all these multiple providers, well, now you have this is an example where you can have performance problems where you ran apply and it would fire up 50 processes, making 100 API calls, and you're wondering like, well, what in the world? Well, the best practice is you should not define any provider blocks in your reusable module. Let your users have that. Don't lock them down, but let them do it. So it's solely contained inside their root module. So you're probably avoiding a lot of issues, not keeping stuff in like that in your reusable modules. Again, your mileage may vary, but they're saying that that's a best practice. So let's see what they gave a couple of examples. They created a provider. They created a module, and they put the required provider. It's just another example with a data call where you're doing another data call and you're applying it so you can see that you're actually working with those multiple providers. So wait, is that multiple providers?
Well, this is the modules with multiple providers.
Okay, gotcha. I want to because I was looking down at my book and now of course I'm scrolling.
Yeah, well, that was multiple providers, but the provider is the same. But it's like multiple providers that are the same across the child modules.
Yes.
It's the next section that I've just been waiting on pins and needles to get into.
It the different providers? Is that the one?
Yes. Okay. It's page 248 where he gets into working with multiple different providers. And like I kind of alluded to at the beginning of our discussion, this is really where Terraform's superpower lies, because you can have one configuration that just builds out everything that you need across all these different things, all these different services, all these different clouds or capabilities or whatever the case is. And I do have a note for a testimony. So if now's a good time for me to launch into this. So like I mentioned, or we talked about, there's thousands of providers that you can use with Terraform. And in the past, I worked with a team where we were using, of course, AWS was our cloud, but we were also using New Relic and Datadog for our observability. And we were
both,
well, I mean, we were migrating from one to the other or between the two. It depended on who had the lower bill at the time.
Gotcha.
So let's just say we had observability platforms at our disposal. But the case was we would stand up our resources, servers, load balancers, databases, or whatever, and then we would go over to New Relic and we would tie everything together. We would say, we want to look at this instance, we want to look at this database or this application or whatever. And it was really, it was toil, because we would stand everything up super automated because we're using Terraform, and then we would manually go into New Relic or Datadog and wire everything together so that we could watch it. And I was like, there's got to be an easier way. We're using Terraform after all, right?
Right.
So of course there are providers for New Relic,
Yes.
there are providers for Datadog, and as you put together these modules for AWS, you can provide all these outputs, which are your EC2 instances, your load balancers, your database, all the information about the resources that were created. And then you could take that output, you can feed it into your Datadog configuration, make sure your Datadog provider is set up with your API key and all that good stuff. And we got to the point where we could, in one pass, deploy all of our resources, and then at the same time deploy all of our observability so that we can look at those resources once they come online. The other sidebar benefit of that would be, say we do all this manual stand up and everything, and say we remove a database or we remove a load balancer or some resource or whatever. Then all of a sudden Datadog or New Relic is going crazy because it's like, hey, what happened? I can't see this, pager alert, et cetera, something's wrong. And we're like, oh, well, we knew this was a problem because we meant to do that. But Datadog's like, well, you didn't tell me.
Right?
It's like,
how am I supposed to know?
Yeah. But now, because everything is synchronized, or it's dynamic, we can remove those resources, and all of the monitoring goes away at the same time that resource is removed. So we didn't have those problems down the road. So all that is to say is, if you have an environment where you're standing up resources, and then there's something sort of downstream that depends on those resources being placed, look to see if there's a Terraform provider for it, wire those things together, and then just stand up everything all at once. It's magical. And
that's actually a good use case. I don't know if our ADOs I haven't seen that yet. And now that you mention it, now I'm going to go digging around and see if I run into that. I haven't seen it yet, but that doesn't mean it doesn't exist. And I'd actually like to see what that looks like. I haven't seen it personally, so I'll have to check that out.
Yeah.
Definitely. All right, we finally made it. We finally landed on the section.
Oh, which one? The crash course on Docker?
Yes.
Oh man.
It should have said crash course on Podman, but I digress. We're not going to get into it.
Yeah.
Oh, do not try to run Docker on WSL. Don't say I didn't warn you. Okay.
Yeah. It takes some finagling, I'll say, to get that. It'll work.
Eventually,
it takes some. Yeah, it takes some hacking.
So this is awesome because it gives you a quick synopsis of, if you don't know what Docker is, it's a container engine, and it allows you to run containers in this example, on your local machine. So it goes through and has you download a container image, and you run that image with an interactive terminal, and then you're dropped down to the command line, and you're inside of this container, and it's showing you the ephemeralness. I wasn't going to, there has to be a word for that, where it is ephemeral. It doesn't exist. But if you go back to a container that you previously stopped, you can see that the information that you put in there is still there. So it doesn't go deep, but it does give you a quick, and it does say it's a crash course, because next it gives you a crash course in Kubernetes.
Right.
And I do mean crash course. So
yeah. I was gonna say, before you go on, I was gonna say, when we looked at this chapter last week, we were like, man, this chapter is long. And then when I started to kind of read through it, I was like, it's long because he's giving these crash courses sort of in the, I guess towards the end of the chapter, before he gets into this big example where he's showing you how to use multiple providers. I will say, I have to give kudos to Jim, though, for saying, hey, I'm about to show you something, but before I show you this thing, I want to make sure you have a base understanding of where I'm coming from. So, hey, here's a real quick aside on Docker. Here's a real quick aside on Kubernetes. And I appreciate him for doing that, because a lot of authors, they may have skipped over that. They may have gone straight to EKS. You know what
Exactly.
I'm saying? Yeah, and then
Exactly.
left you out in the cold.
And
If
now you're like,
you have no clue, you know?
how do I even begin? So I will 100% co-sign that.
Yeah.
It is a long chapter. I think, isn't it like 50 pages or 40 pages? Like,
Yeah,
it's a really
it
long
was a
chapter.
good hump. Yeah.
But the fact that he gives you the resource, the tooling, the understanding of what is this, and I'm going to explain it now. Not the longest examples, but the fact that he did touch on it. You're using Docker Desktop in this example. So if you're, you can't run it on everything, but you can run Docker Desktop, and it allows you to deploy Kubernetes, single node Kubernetes. Great examples here. And then it shows you that once that's done, then you're managing it like you would be managing Kubernetes, but you're not writing a whole bunch of YAML. You're writing. So this was interesting because I did not know Terraform. I mean, I guess I knew Terraform had this functionality, but I didn't know. Like, you think about when you're managing Kubernetes, well, YAML.
Yeah, it's YAML all day.
Yeah, all day. But this example and this use case is kind of like an eye opener. Like, oh my God, Terraform can do all the things. Now, I will not say this is ideal.
Yeah.
Because the fact that I have not seen it, and that doesn't mean anything, but most people who manage Kubernetes is using, if they're using OpenShift, then they're doing it that way. If they're using EKS, they're probably using Helm. There's tooling already around the ecosystem. Yeah. This is just another tool in which to deploy and manage your Kubernetes resources. So I was kind of psyched, like, dang, okay. I learned something else.
And I looked at it in a similar light, because on the one hand, I was like, I just talked about my experience with using AWS and Datadog or New Relic. And I really hope that he would give an example along those lines of saying, hey, we have this one this one cloud we're working with. We're going to work with something totally different. I understand why he kept it kind of close, because that, you have to create a whole nother account and do this whole other thing. That just kind of, belabors the issue. But hey, you can talk about multiple providers that are very, very distinct, very, very different, but they're still in the same ecosystem, which is AWS being the cloud and EKS being the Kubernetes provider endpoint, if that's a good way to say it. So it still got through the example. But to your point, I don't know if beyond maybe the default initial deployment, I would work with a application running on Kubernetes through Terraform.
You would,
because like you said, there's so much other tooling. First tool that comes to mind to me is Argo CD, where you connect it to your repo, you do your YAML, boom, boom, boom. You deploy you check in your Helm charts, and Argo's like, I got it from here. Just sit back, relax. It's going to look at all your stuff, figure out what changed, deploy, update, boom, boom, and you're done. And you don't have to do a Terraform plan, Terraform apply, wait for your, configuration to be, implemented. Argo CD is taking care of that for you automatically.
So if you, listener, are using Terraform effectively inside your Kubernetes environment, we'd love to hear about it. Like, just because we've not done it, maybe we just haven't seen the use case for it. That would be interesting to hear someone's perspective about that.
Yeah, definitely.
Like you just said, that's what most folks do. That's usually par for the course. But depending on, what's happening in your neck of the woods, it could be a myriad of issues why you're using this tool as opposed to other tools that were just mentioned. So we're not poo-pooing it. It's just that we didn't know there was a possibility.
Yeah. The one thing that I would think of, and I don't know, maybe this is a position that people have taken. I don't know. I'm just kind of brainstorming here. But what if you were a shop that was all in on Terraform?
Mhm.
Like you're saying, if you're going to deploy something, if you're going to manage a resource in a cloud, in an application, or whatever the case is, then we have to have a Terraform configuration written in HCL with a provider that goes along with that. So every change is a Terraform plan. Every deployment
Mm.
is a Terraform apply. So then you can almost be like a one-stop shop. It doesn't matter what the end, the end thing is with the service, the resource, the application, whatever. The initial state is always defined from Terraform. Maybe.
Maybe.
I don't know. Yeah.
All right, we're off our Kubernetes soapbox. If you're reading the
Yeah.
book, you'll see that this is a very meaty example. And you run your Terraform apply, you get your endpoint, you can curl it, you can see that you've done the thing. You start in Terraform. And actually, wait a minute, I skipped ahead. I'm sorry. That was the Terraform and local Kubernetes example.
Oh, yes. Yeah,
And
he
then
did do
he
that.
moves over to EKS. Right.
Yeah. So for that that crash course, you did the Docker, did the Kubernetes, like, hey, this is Kubernetes running locally on your system. And then he goes into the example, multiple providers. One AWS provider stands up EKS, and it has all the stuff there, the control plane, the nodes, all that good stuff. And then another provider, which is the Kubernetes provider, which interacts with, it's integrated with this EKS provider that you just deployed. So really, really cool example. It's just I tilt my head sideways when I look at it, so I'm like, I gotta kind of understand it a little bit better. Yeah.
Well,
I would have.
That's
No, I'm sorry.
What were you about to say?
No, I was going to say, after, because as soon as I stood up the EKS cluster, I would be looking for my kubectl authentication, logging in against that. And then everything after that would have been YAML.
Okay. So I just heard you say kubectl.
Yeah.
That's not how I say it.
Yeah. What is kubectl, kubectl, and kubectl. So I mean, I don't know. Maybe I'm from the old school with systemctl and all the CTL
that makes sense.
Commands that come from the Linux side. So when I saw it, I said kubectl.
And I'm a Linux girly too. But when I saw it, well, I think I probably heard someone say it first, and they were like kubectl, and I'm like, oh, that's so cute. And then it stuck, and I don't think I mean, maybe I've said kubectl, but I doubt it.
Yeah.
I doubt it. So anyway, it's neither here nor there. It's the command line tool that helps you manage and
there
run.
You go.
It doesn't matter because you're typing it. You're not saying it.
Yeah, you type it, you don't say it. When I listen to the audiobook, they say kubectl. But for me, I hear kubectl. It doesn't matter how you say it. I hear kubectl. My command line alias is K.
It is. So you ain't even typing all that.
I'm not typing anything other than one character.
Boop. What about Terraform? Is it 2? Is it TF?
For Terraform, I don't have an alias for the command. I have aliases for the subcommands.
Gotcha.
So when I want to Terraform a init, I type init. When I want to plan, I type plan. When I want to apply, I type apply. And I've got aliases or functions that wrap everything together to just make it happen for me.
Mr. Efficient. I know a guy named Anthony, right? And he's an Ansible person. And we were talking about how he turned everything into an alias. And I was like, that's right. And we're talking Ansible. Like, you think about it when you're talking about Ansible playbooks, and then you're talking about Ansible and it's an execution environment. It's like, that's a lot of moving parts. And he had done this whole list of aliases to create. And I was like, okay, this is game changer. And they were so easy to use. So work smarter, not harder. Hi, Anthony, if you're out there. But to your point, aliases are definitely, you know how long those Ansible commands can get.
They can get long.
Seriously. Yeah. So work smarter, not harder. All right. I just jumped all over the place. All right. We're not talking about Ansible, and this is definitely Terraform. We do know that Ansible and Terraform work very well together.
Yeah.
But we're talking about this example of deploying using EKS to deploy containers using Terraform. And this was I did not do this example. I think this is an example that I probably will do, only because I did not install Docker Desktop, and deploying something to EKS is probably just much easier, and I don't have to do that much work.
Yeah, because all you need is Terraform on your system. Everything else is in the cloud.
We already got that.
Yeah, so you'll be good that way. And from the live stream, we got Sterling McKinley joining us. Thanks for joining us today, Sterling. And his quote or comment here is very intricate example. Yeah, it was pretty cool to show how he built out the cluster and then set up the Kubernetes provider right along with it. So yeah, that was pretty slick.
Fantastic.
Yeah, which kind of brings us to the
warnings.
Yeah, to the end of the chapter where
at the end of the chapter. There are also more. Again, this is just to learn the functionality and features of Terraform. And he went through this example and did say that these examples are very simplified. Like these aren't what you'd normally see in an environment. There are no security controls around. There's no RBAC. There's so many more pieces inside of Kubernetes that you have to consider. This is just an introduction as to what's possible. So that's the first warning. This is simple. Kubernetes is hard. The second one is use those multiple providers sparingly. Again, yes, you can do it, but should you? Right? So anyway, your mileage may vary. Terraform has great support for your dependencies and how things happen, but it's better to work just simply instead of trying to put everything together, modularize it. Because again, if a mistake happens, you can keep your mistake local to one particular service or account or whatever the case may be. So use your multiple providers sparingly. And then he ends the chapter.
Yeah.
So this was a good one.
Yeah. I enjoy this one again because, like I said, multiple providers, to me, when you're working with Terraform and you see that capability and you got all these different resources or providers, clouds, stuff that you're working with, and you can put everything in one configuration for everything that makes sense in one configuration, where you don't have to do multiple plans applies. You don't have to do a manual work after the fact, that type of stuff. Let Terraform take care of it for you and take advantage of its capability to interface in just about anything.
Loved it. Well, I enjoyed chapter 7, and oh my gosh, the next chapter is chapter 8. Why are we flying through this book?
We are coming close to the end. And oddly enough, before I get to this, because right around this time is when I start thinking about stuff. So we talked a lot about Ansible in this particular episode, and Sterling comes back. He says, all this Ansible talk, season 6 Ansible, who knows? Maybe, I don't know. That's a good idea. But to my point was, or around this time when we start getting close to the end of the book, even as excited as I am to get through the book that we're reading, I'm like, what are we going to read next?
Always. And we're always looking ahead. We're always looking ahead.
Yeah. So if you're joining us live, watching the replay, whatever the case may be, give us some ideas. Let us know what you're working on. Share the books that you're reading or you've recently read, books that are coming out that you're excited about, or technologies that you're working with that you want to try. And we'll consider them and see if we can work them into the schedule.
I think that would be awesome.
Yeah.
I think that would
but since we haven't finished this book yet, chapter 8 is production grade Terraform code. And I think the goal here for this chapter is to talk about how to level up from some of these basic examples that we've worked with so far, and take it to the next level, working with Terraform as a team, making sure your modules are good. And I think what there was one quote that he said as he closed chapter 7. He said he'll go over several other patterns for how to build Terraform modules for real world production use cases.
That's awesome.
The kind of modules you could bet your company on. I'm like, okay, bring it. Let's see what you got, Jim.
Oh, he set the bar very high, very high. I'm scared now. Wait a minute now. But again, I guess that's we've done the rudimentary.
Yeah.
And he's teed us up to this point in the learnings where now you got to go to the next step. And this feels very next step. Wouldn't you say?
Yeah, I would definitely agree.
Okay.
Yeah, I'm excited for this one as well, to see what he means by production grade, what changes we'll make as far as how we're working with our plans, modules, child modules, root modules, providers, variables, whatever the case is that we need to change or level up on. I'm excited to see what he's going to bring to the table.
Well, I'm excited. I haven't looked ahead at chapter 8, but I'm sure it's going to be a stone gas, and we'll see. We'll get into it next week.
No doubt, no doubt. Well, yeah, as always, Angela, it's been a good discussion. I'm so glad that we got together today to chop it up around this book. I'm going to go back. I'm going to do those EKS examples.
Same.
And maybe we can share some of that next time as well. Yeah, and
awesome.
And for everybody that's joined us live, yeah, thanks for joining us.
Absolutely. So we'll be back next week, same time. But you may catch us on a stream at a later date. Those are always available. But until next time, enjoy your read. I hope you can join us next week. And thanks for joining.
Thank you so much. We'll see y'all.
See you, everybody.